Hi everyone, myself C. Saraswati, working as Assistant Professor, Department of ECE, K.S. Rangasamy College of Technology. Today we are going to discuss about digital fundamentals. So in this slide shows the sum of products. The sum of product is used to simplifying the Boolean expression of logic gates. The words the sum and the products are defined from the symbolic representation of OR and AND functions. Here OR function is denoted as plus sign and AND function defined as dot. Now we consider the three variable Boolean function f of a comma b comma c is equal to abc plus a dash b c dash, and the product terms are abc and a dash b c dash. The product term is defined as either a literal or product of literals, and each product term consists of one or more literals appearing in either complemented form or uncomplemented form. And the literal means each occurrence of the variable in either a complemented form or an uncomplemented form is known as a literal. So in this expression the a, b, c and a dash b c dashes, the first product term contains a, b, c in the uncomplemented form. The second product term contains a dash and c in this complement form. Next, the product of sum. The product of sum is any groups of sum terms under together is called as a product of sum. So the sum terms are defined by the using OR operation, and the product term is defined by using AND operation. Now consider the three variable Boolean function f of a comma b comma c is equal to a dash plus b and b plus c dash. Here the sum terms are a dash plus b and b plus c dash. The sum term is either a literal or sum of literals. Each term contains one or more literals appearing in either complement form or uncomplement form. Next, the standard SOP and POS form. So the special cases of canonical form is a SOP and POS forms. So there are standard SOP and standard POC form. If each term in SOP form contains all the variables, then the SOP form is known as a standard or canonical SOP form. And if each term in POS form contains all the literals, then the POS form is known as the standard or canonical POS form. And each individual term in the standard SOP form is called the midterm, and each individual term in the standard POC form is called as a max term. And in midterms the output result is 1, in the max term the output result is 0. The sum of midterms also known as the product of sum of products, and the product of max term is also known as product of sum. So in this slide we discuss the converting SOP to standard SOP form. The steps to convert SOP to standard SOP form as follows. First, write down all the product terms of the given Boolean function. If one or more variables are missing in any product term, then multiply each of the missing variables and is complement to them, and expand the terms by applying the distributive law and reorder the literals in the product terms. And the final steps, reduce the expression by omitting repeated product terms if any by using the Boolean algebra. So in this slide shows the problems. So the example, f of a comma b comma c is equal to ab plus bc plus ac. So now convert the given expression is standard SOP form. Now the first step, apply find the missing literals in each product term. So the product terms are AB plus BC plus AB and BC and AC. The first product term, the literal B is missing, and the second product term the literal A is missing, and the third product term, the C is missing. So, the second step 2, under the product term with missing literals and its the complement form. So, the f of a comma b comma c is equal to ab into c plus c dash plus bc into a plus a dash plus ac into b plus b dash. Now, the expanded term and reorder the literals. So, now the multiply AB with C plus C dash. So, ABC plus ABC bar plus ABC plus A dash BC plus ABC plus AB dash C. Next, this expression, from the expression omit the repeated product terms. Here the repeated product terms are ABC and ABC terms. So, repeated product terms and replacing only one. So, the final Boolean function f of a comma b comma c is equal to abc plus abc c dash plus a dash bc plus ab dash c. Next, the midterms are underterms with every variable present either the true or complement form. So, for example, two variables x and y, x1 y. So, it produce the 4 combination xy dash x dash y and x dash y dash. In midterms, the variable will appear in its complement form if the value is equal to 0, if the variable appearing in the uncomplement form if the value is 1. Next, the max terms are odd terms with every variable in complement or uncomplement form. So, for example, the two variables x and y produce the 4 combination x plus y dash, x dash plus y, x dash plus y dash. So, in the max terms, the variable will be written in the complement form if the value is equal to 1, if the variable will be appearing in its uncomplement form if the value is 0. So, now consider the 3 variables a, b, c and see the corresponding midterms and max terms in this table. So, the 3 variables there are 7 combinations 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. Now, the corresponding the midterms and max terms for each combination 0, 0. The midterm is a dash, b dash, c dash and the max term a plus b plus c. 0, 0, 1 corresponding midterms a dash, b dash, c and the max term is a plus b plus c dash. The combination is 0, 1, 0. The midterm is a dash, b, c dash and the corresponding max term is b plus b dash plus c. Next, the combination 0, 1, 1. The midterm is a dash, b, c and the max term is a plus b dash plus c dash. Next, the combination 1, 0, 0. The midterm is a, b dash, c dash and the max term is a dash plus b plus c. Next, the combination 1, 0, 1. The corresponding midterm is a, b dash, c and the max term is a dash plus b plus c dash. The next combination 1, 1, 0. The corresponding midterms a, b, c dash and the max term is a dash plus b dash plus c. The final combination 1, 1, 1. The corresponding midterm is a, b, c and the max term is a dash plus b dash plus c dash. The midterm is denoted as m and the max term is denoted as capital M. So, this slide shows the comparison between the midterms and max terms. The midterm is the terms with the product of n literals occurring exactly once and the max term is the term with the sum of n literals occurring exactly once. It is represented by the small m and it is represented by capital M. It is a logical AND of the distinguished literals. It is a logical OR of the distinguished literals. The sum of midterms form SOP function. The product of max term forms the POS function. The output result of midterm is 1. The output result of max term is 0. it works on the active high. In max terms, it works on the active low. So this is some example of the midterms. The f of a comma b comma c is equal to a dash b dash c dash plus a dash b c dash plus a dash b c plus a b c. So the given Boolean expression, each product term has the all the literals either in complement and uncomplement form. So this a given Boolean expression is a standard SOP form, and the a dash b dash c dash corresponding the midterm is m0, and a dash b c dash corresponding midterm is m2, a dash b c corresponding midterm is m3, and a b c and the corresponding midterm is m7. So the midterms are 0, 2, 3, 7. Similarly, the f of a comma b comma c is equal to a dash b dash c plus a dash b c plus a b dash c plus a b c. The corresponding midterm is 1, 3, 5, 7. F of a comma b comma c is equal to a dash b dash c dash plus a dash b c dash plus a dash b c plus a b c c dash. The corresponding midterms are 0, 2, 3, 6. Next, the max terms. The max term is the output is result is a 0. So here the 0 is denoted as uncomplement form, 1 is represented as complement form. So the f of a comma b comma c is equal to a plus b plus c and a plus b dash plus c and a plus b dash plus c dash and a dash plus b dash plus c dash. The corresponding max terms are 0, 2, 3, 7. Similarly, the second Boolean function is the max term is 1, 3, 5, 7, and the third Boolean function is max terms are 0, 2, 3, 6. So next we solve the Boolean function f of is equal to a plus b dash c as the standard sum of midterms. The given Boolean function is f of is equal to a plus b dash c. The first term is missing. The missing literal is b and c. So the b is written as b plus b dash and c is written as c plus c dash. So the first function is written as abc plus abc dash plus ab dash c plus ab dash c dash. The second term b dash c is missing variable as a. So the a written as the true form and complement true form and complement form. So b dash c into a plus a dash is equal to a multiply with b dash c into a plus a dash is equal to a b dash c plus a dash b dash c. The combining all the terms, and finally we get this abc plus abc dash plus ab dash c plus ab dash c dash plus ab dash c plus a dash b dash c. So here ab dash c appears twice, so write only one time. So the final Boolean function f of equal to a dash b dash c plus ab dash c dash plus a b dash c plus a b c dash plus a b c. From this Boolean function the midterms are 1, 4, 5, 6, 7. So next in this slide we are going to discuss the convert POS form to standard POS form. Next the first write on the steps to convert POS form to standard POS form. The first step, write down all the sum terms of the given Boolean function. If one or more variables are missing in any sum terms, then add the product of each of the missing variable and its complement form, and expand the terms by using the distributive law and reorder the expression, and finally reduce the Boolean expression by omitting the repeated terms. So this slide we solve the convert the POS form to standard POS form. So the given Boolean function is f of a comma b comma c is equal to a plus b bar and b dash plus c a plus c bar. So the given Boolean function is the first sum term the C literal is missing, and the second sum term is A is missing, and the third sum term the B is missing literal. So therefore the convert this Boolean function is converted into standard POS form. So then each sum term is add the product of missing variable and its complement form. So the f of the Boolean function f of a comma b comma c is equal to a plus b bar plus c bar and b bar plus c plus a bar and a plus c bar plus b bar. And using distributive law, the first term a plus b bar plus c into a plus b bar plus c bar, and the second sum term apply the distributive law. So a plus b bar plus c and a bar plus b bar c. Similarly third term a plus b plus c bar and a plus b bar plus c bar, and removing the repeated terms. So the final Boolean expression f of a comma b comma c is equal to a plus b bar plus c, a bar plus b bar plus c, a plus b plus c bar, a plus b bar plus c bar. So this is a standard POS form for the given Boolean function. So this slide shows the questions. The questions try to answer these questions. So define the canonical form SOP, write the POS expression for the truth table, output 0 1 0 1. What is mean by midterm? Which form uses max terms, SOP or POS? Define POS form in Boolean algebra. Given an example of SOP expression. How many literals are present in a midterm for 3 variables? State the relation between midterms and max terms. Write SOP form for f equal to 1 when AB is equal to 0 1 and 1 1. Thank you all.